Hey guys, here's just a really quick example of me going over a polynomial application problem. So you'll notice that if you click on the module for homework 16 for applications of polynomial functions, I put a little blurb in there. So really similar to quadratic applications. So let's also keep in mind that quadratic functions are also polynomials. You'll find that the application problems for polynomials in general often are having us either substitute in a value for one of the variables, so either r or t in this example, or solving for a key value like a y-intercept or a relative maximum or relative minimum or any of the x-intercepts. So now that we know so many tools to solve for these pieces, since of course you've watched all of the previous videos, we just need to analyze each problem to try and figure out what we need to solve for. So we are going to go ahead and analyze this problem, but I do just want to put in a little side note that this isn't sort of like the end-all be-all for solving these application problems. This is just an example of one. Maybe the next problem that you do, you solve for a y-intercept, or maybe it has you solve for something else, but this is just an example. So this is a business problem. So for the 12 years that a grocery store has been open, its annual revenue, R, which is represented in millions of dollars, can be modeled by this function that we have here. So this is the function that we're going to be talking about. Where t is the number of years since the store has opened. In which years was the revenue $1.5 million? So this is giving us an example of a revenue here, and I know that my revenue is represented here for R in millions of dollars. So I'm just going to go ahead and substitute in 1.5 into my function. So minus t to the fourth plus 12t cubed minus 77t squared plus 600t plus 13,650. So what I'm going to do is, just to get rid of this sort of lead coefficient, I'm going to divide both sides by 0.0001. So when I do that on my graphing calculator, I will get 1.5 divided by 0.0001, and I should get a value of 15,000 is equal to negative t to the fourth plus 12t cubed minus 77t squared plus 600t plus 13,650. So now what I want to do is I just want to go ahead and solve this polynomial for t now that I have only one variable left in this expression. So what I want to do in order to solve this, or I should call it an equation, what I want to do in order to solve this is I want to first go ahead and set this equation equal to 0. So I'm going to subtract 15,000 from each side. So 0 is negative t to the fourth plus 12t cubed minus 77t squared plus 600t, and when I do 13,650 minus 15,000, I should get negative 1,350. So now what I'm going to do is I'm just going to go over to my graphing calculator. I could put this equation into Desmos and figure out where my x-intercepts are. But now what I really want to do is since we just went over this, I just want to go to my graphing calculator. I want to go into Polysmelt, my polynomial root finder. My order here is 4. I want real numbers. So I'm just going to go ahead and click next. Then I'm going to type in my coefficients. So my first coefficient is negative 1, and then I have my 12 is t cubed. My next coefficient is negative 77. My next coefficient is 600, and my constant is negative 1,350. And then I can go ahead and click solve. And when I do that, it might take a second, but it's going to spit out a few answers for me. It's going to give me the values of 9, 7.07, negative 7.07, and positive 3. So coming back to this problem, where in which years was the revenue $1.5 million? So I am going to go ahead and I'm going to take a look at this positive value, and this positive value. So when t was equal to 3, 7.07, and 9. And we can talk a little bit about why I'm excluding this number. Well, t is representative of that number of years since the store has been open, and so having a negative number of years doesn't really make sense in the context of this problem. So I'm going to go ahead and say that at year 3, year 7.07, and year 9 is when the revenue has been $1.5 million. So there's an example of how to solve a polynomial application problem.